So we are discussing heat capacity. So the flow of the topics is heat capacity, then specific heat capacity, then calorimetry, and the high specific heat capacity of water and its consequences. So we start with heat capacity. The situation is something like this. You have a iron block approximately weighing 3.5 kilograms, and that iron block is being heated by a Bunsen burner. There is a thermometer which has been drilled and placed inside the iron block, which is measuring the change in temperature. Now I give you the scenario that the temperature of this iron block went from 25 degrees Celsius to 50 degrees Celsius. That's a change of about 25 degrees Celsius. And in that duration, when the temperature change occurred, we calculate by some means that the amount of heat energy provided to that iron block was 12,500 joules. So now the question 2 is how much energy it took to raise the temperature of the iron block by 1 degree Celsius. Okay, so that's the question. The heat energy required to raise its temperature by 1 degree Celsius. So how will you do that? This is a standard unitary system problem. Most of you should be able to solve it. So you solve it and then send the answer to me in chat. I'll give you a couple of minutes to do that. All right. So the answer, of course, is a straightforward unitary problem. If there is a 12,500 joules of energy requirement to raise the temperature by 25 degrees Celsius, then if you divide the amount of energy by the temperature rise, then you will get the amount of energy that has been provided in order to raise it by 1 degree Celsius. Okay. So the answer to this, of course, will be 500 joules per degree Celsius, or you can write it as 500 joules per degree Celsius minus 1. So these two things mean exactly the same thing. So okay, in terms of factualness, I made a small error over here, but anyway, don't worry about that. So let us say that the entire body required, that is a 3.5 kilogram iron block, required 500 joules of energy to raise its temperature by 1 degree Celsius. Okay. Now this value that you have got over here is what is known as the heat capacity. Which is something specific to this particular iron block, because it happens to be 3.5 kilograms. Okay. If I had a block that weighed different, if I had a 2 kilogram block, or if I had a 5 kilogram block, then the amount of energy required to raise its temperature by 1 degree Celsius would be different. Are you all able to understand this? Are there any doubts or questions? You guys have any doubts or questions about this heat capacity? No. Sorry? Yeah, the material. Well, right now, let's say the material doesn't matter. So actually, okay, Darshan asked, doesn't the material or what it's made up of matters? Of course it does. And in fact, in this question, there is an interesting mistake that I did, that I'll try to use that mistake to illustrate the idea of specific heat capacity. Okay. So now I can ask the next question. All right, so you required 500 joules per degree Celsius to raise the temperature of 3.5 kilograms of this block. How much energy is required to raise the temperature of 1 kilogram of this block? Okay, so 500 joules per degree Celsius is what was required to raise the temperature of 3.5 kilograms. So if I ask you how many joules is therefore required per degree Celsius rise if I gave you a 1 kilogram block, so how will you work that out? One of you guys tell me how to work that out. Instruct me, I'll write it over here. Sorry, you're saying something? So the just to repeat the problem again, if 500 joules per degree Celsius is the energy required to raise 3.5 kilograms of this material's temperature by 1 degree Celsius, then how much joules per degree Celsius is required to raise the temperature of 1 kilogram? Because we always want to define something in terms of per kilogram, per degree Celsius, etc. So therefore, it's again a unitary problem, and it can easily be solved by just dividing the energy 500 joules per degree Celsius by the quantity 3.5. And approximately, can you tell me what is the answer to that? Sorry, tell me. 142.85. And here again, it's joules per degree Celsius per kilogram. Okay, I hope that part is what you are able to appreciate. Okay, so now I'll tell you what the error that I have made. Can you see what is the mistake that I have made? And it's got something to do with the fact that I called it the material is made of iron. So I'm telling you the material cannot be made of iron.
Because it's too high.
What is too high?
The specific heat capacity. I'm guessing like because it's dependent on a material, it has to remain constant for like.
Yeah. So okay. So to state what this particular quantity is, this 142.85 is what is known as the specific heat capacity. Okay, just the word specific is added to heat capacity. The difference between heat capacity and specific heat capacity is that heat capacity is for that 3.5 kg block of the object. I'm calling it the object because I can't call it the iron. I mean, I can't call it that. I can't say that it's made up of iron, because the specific heat capacity, the amount of energy required to raise 1 kilograms temperature by 1 degree Celsius is coming out to 142.85 joules. And iron specific heat capacity happens to be somewhere around 450 joules per degree Celsius kilogram. Okay, so that was just an error in my part, and you can figure that out by a table that is there in page 265, and you can look at that table and tell me what this substance could likely be. Actually 142 corresponds to something like mercury. It can't be a block of mercury, because mercury at this temperature would be liquid. So therefore this is some substance which is not there on that table, and this happened only because I made an error. What I should have done is multiplied this 12,500 by a factor of 3.5. Then I would have got the correct specific heat capacity. Okay, so the error gave us an opportunity to look at something in a slightly different way. But I hope the idea of heat capacity and specific heat capacity is not confusing at this point of time, because students often make a error in understanding heat capacity and specific heat capacity. So I'm just repeating it. Heat capacity is the amount of energy required to raise the temperature of any given object by 1 degree Celsius. Its mass doesn't matter. Okay, whereas specific heat capacity is the energy required to raise the temperature of 1 kilogram of that substance by 1 degree Celsius. So if this is clear to you, then we are almost sure and dry.